Awesome. Well, okay, let's go ahead and get started. Really excited to be here today. Thank you so much to the Injective team for hosting this, and really excited to jump more into Cascade, which is the first Interchain Solana SVM rollup. And thank you so much for joining us today, Neil and Eric. Maybe we could give a little bit of an intro, a quick intro for both of yourselves. Neil, if you wanted to go ahead and get started.
Yeah, sure. First, thanks to the Injective team for organizing this Twitter Spaces. So some context is that Eclipse offers customizable rollups as a service, meaning that you can build your own rollup. You can specify what virtual machine you want, what base layer you want, and whatever additional customizations you want for your rollup, and deploy your own chain.
Awesome. Eric, you want to give a little TLDR on Injective?
Yeah, hey guys, this is Eric Chen, co-founder and CEO of Injective Labs. So Injective is a blockchain built for finance. It's a highly performant and interoperable blockchain with a lot of custom out-of-the-box modules for DeFi developers or any type of financial application developers to leverage. And we're really excited to work with Eclipse on building the Cascade, which is the very first Interchain Solana SVM rollup.
Bringing together the Solana and Cosmos communities. So exciting. So I think before we start getting into Cascade and specifically what that type of infrastructure looks like, it'd probably be helpful for us to start explaining a few concepts to our audience here who may not be familiar with some of these terms like SVM and rollup. So let's start with what is exactly the C-level Solana SVM and what is it used for? Neil, if you want to take that question.
Yeah, maybe the right way to approach that is first by talking about the EVM. So the EVM, or Ethereum Virtual Machine, is what runs programs on the Ethereum blockchain. And this is probably the most popular VM in crypto because Polygon, BSC, so many other chains have adopted EVM compatibility. The problem with the EVM is that it's single-threaded. And that's useful for many reasons because, for example, the state is in a Merkle tree, and updating a Merkle tree is very easy if you do it sequentially, and that's necessary to implement it as an optimistic rollup. But the downside of the EVM is that since it's single-threaded, it's extremely slow. So the TPS of these EVM rollups maxes out on the order of like a few hundred transactions, and this is for highly efficient proof-of-stake blockchains or for the best EVM rollups. If you look at Solana or the SVM, this can reach tens of thousands or even hundreds of thousands of transactions per second under optimistic assumptions. So that's the reason for using the SVM. On top of that, you can use a ton of different languages with it. You can use Python to write Solana programs now using things like Seahorse Lang. They have these local fee markets, meaning that if there's an NFT mint and a ton of people are trying to mint an NFT, then other users on the blockchain are not affected. Whereas if the same thing happened on Arbitrum, for example, all the users are going to experience this massive gas spike. So these are some of the reasons to use the SVM. And by deploying an SVM to Injective, this means that projects from Solana can easily go multi-chain to the Injective ecosystem.
So exciting. And we can kind of get into a little bit more of like what exactly a rollup is and what kind of that role is interchanging with the SVM, how that's going to be worked in with the chain infrastructure. Question for you, Neil.
Sorry, could you rephrase that?
Yeah, so getting into what exactly is a rollup for those who may not know and how that's going to play a role specifically within this architecture since it's a modular rollup. So going into that concept.
Okay, yeah. So rollups are a concept that come from like the Ethereum scaling roadmap. So historically, if you wanted your own chain, that means that you have to secure that chain. And formally, you can define security as the cost to alter history of a blockchain, meaning a transaction occurred and then there's some amount that you can pay to attack that blockchain and undo that transaction or move it around or something like that. So that's how Ethereum works. That's how Bitcoin works. They each provide their own security. Where Bitcoin is proof of work, meaning that there's some amount of compute that runs the network. And you might have heard this term 51% attack. That's basically the amount of compute power which can be converted to some rough number of dollars that'd be required to attack the Bitcoin network. For Ethereum, it's a proof of stake network now, so there's some amount of stake where you could basically do something very similar. Um, so it's called like a long range reordering attack. But the a roll up is like an alternate way of spinning up your own chain, which borrows security from some existing blockchain. Where the most popular roll ups right now are Optimism, Arbitrum, Starkware, and there are two types of roll-up constructions. One is optimistic, where you just go ahead and compute whatever you want off-chain, and then you commit the result to a blockchain like Ethereum. And retroactively, anyone can look at that result and say, hey, that result was not computed correctly. And I'm willing to bet money that it was not computed correctly. And Ethereum will re-execute that on chain and determine who was right. And someone will lose money and someone else will make money. And alternately, you can do a ZK rollup, which is the direction that the Cascade rollup is heading in, which is that when you can compute the result of a program, you additionally compute some evidence. And this sounds like magic, but you can give some additional proof that a program was executed correctly. So it's like a version of AWS, for example, where when you ran programs on AWS, Amazon also gave you some proof. And they're like, hey, here's the result of your program, and here's some magic little evidence that tells you that it was actually run correctly. So those are what rollups are at a high level. I know it's like a little hand wavy, but there's a ton of literature on rollups. And in this case, the rollup is intended to borrow security from Injective in the short run.
Yeah, and there's a few benefits for that we can get into a little bit later in the space, specifically for Injective and for you, Eric. So Cascade is the first Interchain Solana SVM rollup. So we've kind of talked a little bit about those two terms and what those mean. But can you explain what Cascade is exactly and how that will work within the Injective ecosystem?
Yeah, of course. So Cascade is a SVM-based environment where it's identical to the kind of smart contract or program environment for Solana, and this basically unlocks kind of like an $8 billion developer ecosystem with some of the most brilliant high frequency trading DeFi like high frequency trading developers or different types of very innovative developers focusing on highly scalable and highly performant applications servicing kind of these advanced DeFi space and bring them on to Injective, which has a very specific goal of kind of onboarding cutting edge and bleeding edge DeFi applications and making sure that they're all well synergized and the entire community of Injective evolves around kind of like the needs and wants of DeFi developers or just very much of a sector focused kind of evolution. And clearly, this is a very natural synergy where these developers get to be able to participate directly with the Injective ecosystem via Cascade by deploying their applications there and evolve their applications into something that has a very seamless marriage with the core Injective ecosystem while ensuring sovereignty in the sense from the Injective main chain within the Cascade environment. To have a lot of really cool, use cases, to have a lot of really novel kind of specific applications, and basically enjoy kind of like the possibilities by merging, Injective's native Cosmos environment and some of the blockchain modules with the kind of like a Solana enabled development environment as well.
So circling back to like a technical level here, we've kind of gone over why Cascade is significant, but are there any other implications that the Solana VM rollup on Injective is going to provide? And ideally, we would explain these in everyday terms so that we could share with our audience what those benefits are going to be to them. Neil or Eric, whoever wants to take that question.
Yeah, well, one pretty obvious benefit is that it brings this super fast virtual machine to Injective, meaning that if you want to write something like a fully on-chain game or something like that, or if you want to write a physical infrastructure network, most chains typically can't accommodate that kind of throughput requirement, but you could deploy that to the SVM chain.
Yeah, I think from the kind of eyes of the general user, some of your favorite Solana applications. I won't name names for now. We'll be kind of seeing a new destination on top of Injective or Cascade in some cases, and they'll help you explore, hey, what's a Cascade about or what Injective is about. And on top of that, some of them might even have evolution and user experiences. Like, oh, like now I can, use my favorite Solana DeFi project, or some of the DeFi projects out there, but with the Ethereum wallet and with a much deeper spot liquidity, or enable a much more seamless margin trading or derivatives trading, and perhaps even for some cases, for like injective heavy users, maybe some of your applications that you're using today or certainly have like NFT functionalities, or maybe some of the lending functionalities and stuff like that. And this is all enabled by Cascade by tapping into this massive developer ecosystem.
And a question for you to kind of follow up on that, Eric. How is this different from building on Solana specifically? Is there anything that developers should know when working with Cascade?
Yeah, and basically this is a tightly coupled ecosystem. Cascade, is secured by the injective ecosystem, and will be, much more further secured, during during the course of evolution. But more importantly, there's going to be a lot of the interoperability and very interestingly, a lot of the tight composability that comes with, being instant finality with the core property of the injective chain. So this means that unlike you using the application on top of Solana, which requires a bridging process, which may lose atomicity perhaps, or have very very weak composability experience, Solana applications or SVM applications on top of Injective means that it's highly tightly coupled with applications on top of Injective, or the other way around, where injective applications are further enhanced by kind of like the Cascade SVM environment. And this means that sometimes you might not even notice that you're using Cascade, or vice versa, where you're on Cascade and you're not even noticing that liquidity is tapped in from the injective chain, or a lot of the core primitives are leveraging injective chain primitives. On top of that, one of the biggest differences is that a lot of the injective native applications are based on the Ethereum key derivation, and one of the advantages of Cascade is that over time it can kind of resolve these type of differences and ensure that users have a multi-chain universal identity, and making sure that it's a very seamless experience, traversing through this multi-chain world.
Yeah, 100%. And that's where we all are trying to be, I think, is really just, getting it to a point where, everything is just so seamless for the user that they won't even know what type of chain that they're on, ideally. And so to go a little bit more into this now, what specifically is now possible that wasn't possible before with Cascade? Either Neil or Eric, whoever wants to take that question.
Oh, I can go first. I mean, for the first time ever, if you're a Solana developer, if you've built application on top of Solana before, this is the first time, without even having it touch a single line of customizable code, you can start deploying onto what's practically injective. You can start just basically deploy your application, everything that you've done on top of Solana, and migrate it or deploy it onto Cascade, and you basically get to be in touch with the hundreds of thousands of injective community members. And this is probably one of the most exciting things for a developer right now.
Yeah, another thing is indicated by the title of this Twitter space, which is these are the first SVM chains that are actually IBC enabled, meaning that you could actually pass an IBC message and reach the rest of the Cosmos ecosystem.
A follow-up question to that then. What is required for developers to start deploying, and what does that process look like?
So it's pretty similar to an app going multi-chain from the Ethereum ecosystem, meaning that if you go to the Cascade docs, we'll share some instructions, but you basically point your CLI to the Cascade RPC, and then you go ahead and just deploy your application, just like you were deploying your EVM app to another chain using Truffle or something like that. And then, of course, you have to modify your front end so that it's aware of this new RPC network.
Very, very exciting. Another infrastructure question for, well, I guess it'd probably be for Eric here. Um, how will the Cascade rollup operate alongside the primary injective L1? And how does the scalability differ between the L1 and the rollup? Just looking for the relationship between those two things for those who may not understand.
Yeah, one of the most direct way for these two environments to interop is via the IBC connection that's going to be established between Injective and this Rollup layer. And because IBC is not just kind of like an interchain bridge, but rather a generic message passing protocol, this allows for anything to be passed between Injective and Cascade through a universal messaging standard. And this means that it's not just about IBCing token over. It's also about IBCing the state over, IBCing any type of relevant information that wants to be passed in between them at pretty much the identical block time as Injective. And so this means that the rollup layer gets to almost have like a first-hand access to all the happenings around Injective, and vice versa. And this also means that Cascade has almost instant access, or zero delay access to all the happenings around Injective as well.
Awesome. Great. Thank you so much for that answer. So we've talked a lot about the infrastructure between Cascade, Injective, what the Eclipse is specifically bringing to Injective. What looking towards the future of this chain, because as of right now we have a first time product here, but what are the hopes for the future for Cascade, looking down the roadmap for either Eric or Neil, whoever wants to answer that question?
Yeah, so I don't want to reveal too many details about some of these plans in the future, but some of the most interesting Cosmos technologies, there's like a roadmap to integrating these into the Cascade rollup. So we're pretty excited about that. Down the line, of course, there's a decentralization plan, and right now, while it's starting as an optimistic rollup, it'll become a ZK rollup in the future. So these are some of the technical developments that we're pretty excited about.
Yeah, and I know Injective is planning to bring Celestia into the fold as well. Eric, would you mind giving some color to that aspect as well?
Yeah, I think it highly synergizes with the overall modular blockchain thesis of Celestia, and ensures that there's a safety and security amongst various layers of the rollup solution itself. And we're really glad to be working with Celestia team, and obviously a lot of their technology powered what's composed of Cascade at the present moment. And I think like going forward, there's going to be a tighter and tighter collaboration with Celestia around expanding more rollup solutions, more various contract environments, and even experimenting with different types of trust assumptions, security assumptions when it comes to rollups.
And is there anything else that we want to, share along the broader goals and vision for Injective and Eclipse? Either Neil or Eric, whoever wants to take that one.
Yeah, I think through this launch, Eclipse has demonstrated that they're very, very strong builders, and they are capable of executing and bringing a very, very exciting concept into production really, really quickly, instead of just saying you're going to build it and show up like a year later with a test net. And that also creates a lot of that also signals like a lot of our excitement around the work that Eclipse is coming up soon, especially around building more composability layers, building more and more secure kind of like a roll-up solutions, such as kind of like a ZK roll-up. And I think there's a really great bright future ahead on the collaboration between Injective and Eclipse.
Sorry, I can just add on to that. Yeah, this is like an example of a 10 out of 10 Eclipse chain that we'd love to see. So that's why we're excited about this partnership, in the sense that we have like these chains that can, I mean, support different virtual machines, support different types of gas, and this takes advantage of the best of those features. And if you just look at like the last month of the Injective ship, what they've been shipping, a lot of really interesting developments. So I think this fits in really well with that.
Yeah, there's also the Injective Hackathon, which wanted to mention here, in a bounty program. So just a reminder to everybody here who's really interested in not just Cascade, but in general what Injective has to offer here. I know it's open to register and it starts April 10th. So any developers interested in participating, definitely visit injective.com and click at the pop-up window to get started there. And we also do have the Cascade developer docs for anybody who's interested in diving into that a little bit more. I don't know, Mirza, did you have any other questions that were top of your mind?
No, I think that covered things pretty well. I think generally, one thing that might have went over people's heads is how complex it actually is to bring over the code you might have on Solana over to Cascade. I think that's the main selling point here, that you don't actually have to rewrite the code. Could you actually sort of chat about that part specifically? Like, if you are a dApp on Solana, how would you port over to Cascade?
I think you kind of mentioned it before. It's basically like just switching an endpoint and doing the exact same thing you did for Solana for a first step. Obviously, we want to make it a much more well-rounded application, especially on like being composable. You have to do more work, but getting the 0 to 1 phase, it's like as simple as just switching an endpoint. Correct me if I'm wrong.
Yeah. No, that part's pretty clear. But with the other sort of additions to the Cascade layer itself, so let's say when you change the data availability layer, etc., what impact does that actually have on a dApp that's already, let's say, utilizing the Cascade testnet?
So it should be a seamless experience. Well, no matter how it's implemented under the hood, it'll still look like an SVM to the end user or to the developer. But yeah, under the hood, let's say you're using a block explorer with Cascade, then you'll notice that the links to the DA layer will change. Maybe you're on Celestia one day, and then you switch to Avail another day, or go to Eigenlayer. Then you can actually see the progress of a block being posted, depending on like the chain that it's being posted to.
Cool stuff. Yeah. And the other last part I want to highlight is Eclipse is sponsoring a bounty for the hackathon, which is pretty exciting. So yeah, for Cascade specifically, there's a bounty. So if you're building something specific to the SVM layer or anything related to Cascade, yeah, excited to see you guys there.
Very, very, very excited about the hackathon. And just for those who were interested, I know we talked about the developer docs before. I did pin that to the top of the space. So anybody who's interested in going to check that out, the link is in that tweet. And yeah, I think we're good to wrap this up. I think if anybody has any questions related to Cascade, feel free to reach out to the Injective or Eclipse teams. We would be happy to answer any questions that you have. And also make sure that you check out the blogs published recently if you're looking for more information. Injective has a blog article on this, as well as Eclipse has a technical deep dive. So yeah, go check those out on our websites. Make sure you're following Injective and Eclipse teams on Twitter. And thank you so much, guys. This has been such an informative space. Neil, Eric, Mirza, appreciate everybody joining today.
Yeah, with this announcement, if you're a Solana developer, now you'll have a much easier time competing in the Injective Hackathon. So anyone's welcome.
Come one, come
Yeah,
all.
if you're a developer, you should look at the bounty program, and then also check out the Cascade docs. And you can go ahead and try deploying something that maybe already exists in the Solana ecosystem, or deploying your own app.
Awesome. Thanks so much, guys. I think we're good to wrap this up. Thank you so much, everybody, for joining today. Yeah, just again, make sure you're following us for any further news. We're going to be dropping alpha as things develop with Cascade. And yeah, stay tuned. Thanks so much, everybody, for joining.